So today what I would like to do is just go over the lab and then show you, give a little demo of each of the experiment so that you can see how it's done. And if you don't have the material, I will show you what material to use so you can identify it in your lab packet. Or if you if it's not there, and I think you might not have the ethanol there, but you have some ethanol in your alcohol burner, so you can use that. Or if you have a hand sanitizer, you can use that too. So what I would like to do again is just go over the lab, make sure you understand what to fill out, and then give you a small demo of some of these procedures. So first, you guys are going to find that particular experiment on week 13. I can't believe we're in week 13, which means we only have 3 weeks left after this week. Okay. This, of course, the A part just gives you the information. You can watch these videos. Okay. That was taken when this experiment was conducted at Miramar College. You can certainly, I will go over the PowerPoint as well, and the YouTube discussion from, I think, the previous semester, and a description of the experiment. And if you click on that, this is the description of the experiment. Notice that I tell you what material you should have in your lab kit, what chemicals Miramar College should supply, but I noticed that ethanol might not be there, okay? And what you guys need to supply. Something like baking soda, okay? And vinegar is something that you would use. We're not using muriatic acid. And I put in bold words here, substitute acetic acid, which is nothing more than vinegar, for muriatic acid. Okay, because muriatic acid's a little bit more harsh. Vinegar is pretty mild. Okay, you put it in your food, so that's, and it's an acid. It'll do the job. So this is what you guys will need. You need your alcohol burner. What I have, actually, I will be able to do this experiment with just a little candle. That'll work too. Okay, so these are the materials. Okay, and what I would like to discuss is how to fill out the data sheet. And part of filling out the data sheet is the evidence that a chemical reaction has occurred. Okay, what is the evidence that a chemical reaction has occurred, so that you guys can write this down. And then again, what is important is your detailed observations. So don't just put words like, oh, turns blue. Actually write in sentence form what you are observing. That's part of being a good scientist. If you're going to be in the medical field, you guys are going to have to write reports of your patients. Learn how to write in sentence form the observations that your patient gives you. Okay, that's very important in terms of making sure that they're in the path to recovery. So these are things that, yeah, chemistry reactions are not medical things, but you need to learn these little things so that you can apply it to the bigger picture when you actually are working in your career. So if you just read through this, it kind of gives you directions of the procedure for each little step. The reactions themselves are not very involved. They're usually one step. Okay, they're done in like less than 5 minutes. And then here I want to mention that what you need to do is you need to write what it looks like before the reaction. Before you even start it, what do these things look like? Like one of the first reaction is where you take the copper shot. Okay, well, what does the copper shot look like before you start that reaction? Okay, and then in the process of the reaction being carried out, write down what changes are going through, and then also write right here, appearance after. So be a little bit more descriptive. If you need more room, then please use more room. Evidence of the reaction, I'll talk to you guys about that, and then balance the equation. Now, some of you might not know how to write the formula. Okay, the formula of these chemicals is given to you throughout the direction. Like if you want to know what is the formula of copper shot, okay, I tell you what it is. It's just plain copper. What's the symbol for copper? And air. What is the main ingredient in air that is going to be reacting? So now you know right here what the two chemicals are and what your products are. Okay, so that's what you put right here in terms of that. And in fact, I actually tell you in the heading, this is the reaction: oxidation of copper by air to produce copper 2 oxide. You guys should know how to write the formula for copper 2 oxide. Here, conversion of calcium oxide, that's lime water, okay, to carbon dioxide to produce calcium carbonate. What's the formula of calcium carbonate? I actually give you the hint of what equation to write right in the heading of all of these. And if you don't know what calcium carbonate looks like, might be, then you need to go in here and maybe it'll be written in the direction somewhere. Okay, so again, that's what you need to do for each of your observations, is to fill this in. The more details you have, the better off your points will be for each particular section. And then you guys are going to be asked to balance the chemical equations for some of these. And again, I actually give you hint, like this one's a single displacement reaction. Go to this YouTube video, go to the 1 hour, 6 minute mark, and it'll give you an illustration of what a single displacement reaction looks like. Okay, this is a double displacement reaction. And if you go to this right here and you go to the 1 hour mark, then it'll give you information on that. So I give you a hint throughout the procedure of guidance of how to write up these things that might be obscure. This is the actual lab manual that you guys will have downloaded. It's basically what you saw right there in the PDF in Canvas. So let me go ahead and talk to you about this right here. Talk to you about this experiment. So we've already covered balancing chemical equations, so I'm not going to really do that. Make sure that when you write the chemical reactions, you are as detailed. You need to put the phase, you need to put down the arrows, and you need to make sure it's balanced. Okay, so that's
Excuse me, Professor.
Yes.
So about the rubbing alcohol thing, I'm able to substitute hand sanitizer for it?
Yes, you can.
Right.
I'll show you that demo, okay? So yeah, you can do that. The only reason why you have rubbing alcohol is to make sure it burns so you can see the combustion reaction. Okay.
And
so
hand sanitizer burns just as well?
If you look at the ingredient, 65% ethyl alcohol, ethanol, 65%. So yeah, it'll burn. Okay. So and now again, when we get to that point, I'll show you. Okay. So when you're looking for evidence of a chemical reaction, these are the evidence. When you see gas or you see flames, that shows that you have gas formation. So that's the evidence that a reaction has occurred, and that might be the combustion of ethanol or the ignition of sugar. Okay. When you see a precipitate form, and a precipitate is like this, where you have two liquid, transparent liquid, and when you mix it, it starts to form this cloudy solution. Well, that's a precipitate. If you let that cloudy solution settle, it actually collect as a solid at the bottom. Okay, so that's a precipitate formation. When the temperature changes, usually it'll get hot or cold. That means that bonds are breaking and bonds are forming. That's sign of a chemical reaction. So these four right here are signs that a chemical reaction has occurred. When a color change has occurred, and it's not because you mix two ink, you mix a red and a blue and get purple. No, it's because a chemical reaction, a new product has formed, and that new product has a different physical characteristic. Okay, so these are signs that you want to write down depending on the chemical reaction you carry out in order to provide to show that a chemical reaction did occur. Okay, so these are the different types of a reaction. Remember, when you take two chemicals and you combine it into one, that's a combination reaction. Like if you take sulfur trioxide and water and get sulfuric acid, that's combination reaction. When you take one chemical and break it down into parts, that's a decomposition reaction. When you take some sort of fuel in the presence of oxygen and burn it, so you get carbon dioxide and water and energy, of course, don't forget energy, that's a combustion reaction. This right here is this part right here, here it is, my mouse, is a single displacement. What happens is that one element removes a partner for this ionic substance, this salt. This is a salt because it's got a cation and anion, and replaces it. It's a single displacement. This is the general form. Even calcium with water is a single displacement, because what calcium will do is replace one of the hydrogens in HOH. HOH is water. Replaces one of the hydrogens, and you get calcium hydroxide. It takes two waters for this reaction to occur, but that too is a single displacement. Double displacement is when partners switch, and you see a double displacement in acid-base chemistry, and you have an acid reacting with base, or this right here where you've got an ionic substance or both, and then they simply switch ions. The barium nitrate and the hydrogen sulfide, the hydrogen and the barium will switch place, and what you get is barium sulfide, and hydrogen nitrate or nitric acid. So that's a double displacement. Or you can have an acid base, which is also a double displacement. The H will replace barium and form water, and the barium will replace H and form barium nitrate. H, will replace NH4 and form water. NH4 will combine with Cl to form ammonium chloride. So these are different types of chemical reaction. And more specific, you have acid base is a double displacement, but it's a form of double displacement. The next few slides shows you more examples. Okay, and again, I think we covered this back in chapter 7 when we did that in your activity. Okay, and here I actually show you how to balance a double displacement reaction. Okay, so let's take a look at the experiment itself. In the experiment, the first experiment that you guys are going to be doing is the combustion, or not the combustion, but the heating of copper with oxygen. So here's what I'm going to do for you. The first reaction is simply the heating of copper. So if you have your alcohol burner, okay, you can see I've got a spoon, and I'm just going to put my copper shots right here. So you want to make sure that you observe what the copper shot looks like, make a description of that, and then what we're going to do is just heat it up and let it heat up over time. And so this might, because we're not using a very hot flame, it's not like you guys have a Bunsen burner. You guys are going to have to take a little bit longer. But this is basically what's going to happen. You're just heating it up, and then you want to watch the discoloration of the copper over time. Now, the reason why this might take a little longer is because the spoon might not be a very good conductor of heat, but this is all you do, okay? And if you've got a stand, just let it sit there for about 5 minutes. But if you look closely, some of the copper is already getting discolored. And so make it go for a good maybe 10-15 minutes so that you can actually see something going on. So that's what you would do in this particular procedure. Okay, so I'm going to put this down. Okay, so this is basically this reaction. Here you can see the copper shots, and it's over a really hot Bunsen burner, and we're just heating it up. And because the Bunsen burner is so much hotter than a candle flame, then that reaction will go much quicker. Okay, so I'm just scrubbing through, and there you can see the discoloration where it got really hot. So that's the first reaction. Okay, that's the first reaction. You want to make sure that you are able to describe what happens, what it looks like before, what it looks like after, the evidence of a chemical reaction, and then the balanced chemical reaction. Okay, that's the first reaction. The second reaction is taking calcium oxide with carbon dioxide. The chemical that you want is this chemical right here. It's called calcium oxide. It's also called lime water. And what you need to do with this lime water is the following. Find a test tube, pour some of that lime water in your test tube, take a straw. Then what you want to do is take your straw, and you're going to supply carbon dioxide by your breath. Okay, so let me just show you how that works. So here it is right here. And I'm just going to put a straw right here, and then I'm going to blow in. So you can see that it went from clear to a cloudy solution. Remember what I said about cloudy solution. If you keep blowing, you get more cloudiness. And if you let it settle, you actually see something settle towards the bottom here. All you're doing is taking this calcium oxide and adding carbon dioxide. And this right here is nothing more than chalk, calcium carbonate. Let's watch this movie so you guys can see that. And again, I'm just going to scrub through. Here's lime water, looks like plain water. And here it looks like it's just water, and then I'm blowing off to the side. And I didn't do a very good job centering it, but I am blowing. And here you can see what goes on. That's your reaction. That's your reaction. That material that's cloudy, it'll look like this if you have enough of it. Okay? Your third reaction, you guys need a beaker of water. Let me show you my screen. Okay, you guys need a beaker of water. Just put it right here. And then you need to put salt in that beaker of water. So I've got a little bit of kosher salt right here. Okay. Right there. And I'm just going to sprinkle it in. And the reason why I need to do this is because I got to get some electrolytes in here. And then I'm just going to stir it so that I get a solution. Now, you don't have to get all the salt to dissolve. Now that I have my electrolyte, I'm taking a battery. You need a 9-volt battery because the 1.5 is not going to be powerful enough to do this for you. Okay, let me just put my laptop on my lap here so that you have a better view. You're going to take this battery, and all I'm going to do is dunk it in. Okay, and as I dunk it in, watch the bubbles. You're actually doing electrolysis. Notice that one side of this battery is generating more gas than the other, but they're both generating gas. But one is forming gas twice the volume of the other. What's the formula of water? H2O, 2 hydrogens per 1 oxygen. So you know which side is generating the hydrogen and which part is generating the oxygen. And that's that reaction right there. When you are done, please remove the battery and then dump your water down the sink. You don't want anyone to mess around with it. Dry your battery off and then probably dispose of it in a like Home Depot. But that's your reaction. That's the reaction for this right here. Let me show you the movie so that you guys can see what it looks like when we do it in the lab. And when we do it in the lab, we are much more sophisticated than just dumping in a battery in there. We actually put in the electrodes, and then we use carbon graphite as our electrodes. Dumping in the battery just makes it so much easier. You don't have to worry about extra equipment. Put salt in there, put the terminals, and then you guys can watch as bubbles form. Okay, here. Again, you can see that one side of the electrode is generating twice as much bubbles as the other. And that's the experiment. Okay, that's the experiment. So let's move on to the next one. The next one is this combustion of sucrose. If you use your sugar packet from the last experiment, then just take CNH sugar, but you should have gotten 2 sugar packet. You should have gotten 2 sugar packet. Okay, if you don't have that sugar packet, CNH sugar will work. Get some CNH sugar, and you can do this. So all you need to do is again, get a spoon about that amount. Okay, that amount. And then we're just going to burn it. Now, if you have a alcohol burner, then you should be able to get this thing going fairly rapidly. But again, we're sort of limited to the amount of heat that we have here. And what we're doing is just caramelizing it, and but it should ignite. If you have a stove top with a flame on it, you can do it there too. Anyway, you get the idea. I just don't have a big enough flame for this.
It's supposed to ignite?
Yeah, it's supposed to ignite. It's a fuel. Okay, sugar's a fuel. It's not going to be a very big ignition, but you should see some sort of ignition. Let me show you the movie, because apparently my flame here is not strong enough for that. So here it is again. I'm going to scrub through. And here is the Bunsen burner. And we're using what we call a deflagonation spoon, which has a very long handle. And what we're going to do is we're just going to put it in this very hot flame, the Bunsen burner. You can see the blue in the Bunsen burner, so that means it's really hot. And with so we're going to caramelize this. Here you can see the sugar burning. Okay, and it's just boiling it, and you're caramelizing the sugar, and then you're actually just getting rid of the sugar's called carbohydrate. So it's hydrates of carbon. When you remove the water, what you have left is carbon, which is that black tar. But you're also combusting it, because that's a combustion process. You're forming carbon dioxide and water. Okay, so that's the demonstration for this particular lab, and that's it. That's the one step. Okay, again, write what it looks like before, write what it looks like after. So let's take a look at this right here. This is the reaction with muriatic acid. Now, this is a tricky one, because you're going to do it under 2 conditions. Okay, you're going to do it under 2 conditions. One condition is just plain water, and then you guys are going to add phenolphthalein to this. And the reason why you want to add phenolphthalein is because you want to see whether or not the reaction is going to generate some sort of product. So let me show you this movie first. So this is hydrochloric acid with magnesium ribbon. And whether you use hydrochloric acid or acetic acid, they both will work. Okay, they both will work. So let me let you guys watch that. I got to get some water. Let me scrub through this so it's a lot quicker. So again, I'm just putting hydrochloric acid on these. I apologize for the granular resolution. I took this a while back when they didn't have 1040 resolution. So what I'm doing is here you can see that with water, it's turning the solution a little bit pinkish. Okay, it's turning it a little bit pinkish, not a lot, but enough. And then with the acid, you should start to see bubbles. So let me fast forward this quick. There. So that's what it looks like. Let me just show you what it looks like when we do it live. This is Petri dish. This is with water. The chemical with in here has phenolphthalein. Now what I'm doing is adding some water to this. And then on the other one, what I will do is I will add some acetic acid. So if you look real closely, it looks already discolored. Okay, it already looks discolored. I apologize for this label. Let me see if I can't close this and then close this and then remove this label so that you guys can actually see what's going on. Okay, that should be enough. You guys should be able to see that it's already turning pink, which means that whenever you see phenolphthalein turns pink, it means hydroxide is being formed. It's becoming more basic. So you just have water, and the water is breaking down, probably reacting with the magnesium, and you're generating OH. That's what you see. So let's take a look at this right here with vinegar. So the vinegar that I am going to be using is this plain old, you guys can't see that here. You guys should be able to see this. Plain old Costco vinegar, okay? It's Costco vinegar. It's 5% acetic acid. You can see right here. And what I'm going to do is I'm just going to pour some of the vinegar into this Petri dish. Again, we're not using uric acid. We're just using the vinegar. And right away, it's bubbling. That's all you want. You just want to see the evidence. So on the one hand, with water, it turns pink. On the other hand, with vinegar, it's bubbling. So we don't need hydrochloric acid. Hydrochloric acid would be overkill. We need common chemicals that you guys find in your kitchen. And you can see that thing is really bubbling. So that's it. That's your reaction. There's a lot of bubbles. I didn't realize that reaction would really be very efficient with acetic acid. Okay.
Did we put metals in there?
Yeah, magnesium.
Oh,
That's what the direction says. You take magnesium and you put it in with vinegar. You take magnesium and you put it in with water. That's magnesium right there. It's a magnesium ribbon that we had. This is what the magnesium ribbon looks like. Okay. So that's, like I said, these series of reactions are not difficult, but you want to write down your observations. This is the combustion of ethanol. So this one right here is the one in which you can do several alternatives. Let me show you the first alternative. If you don't have ethanol, you can use vodka. Vodka works just as good. If you guys have vodka in your cabinet, then that'll work. If you don't have ethanol, then you can use nail polish remover as well. So let me just show you how this works. What I'm going to do is I'm going to pour a little bit of nail polish remover right on my spoon. Oops, that's too much. That'll give me too much. And then I'm just going to heat it up. Oops, you can see it's burning. Okay. This hand sanitizer right here, if you look real closely, what you will see here is that the ingredients of this says at the very top, ethyl alcohol, that's nothing more than ethanol, 65%. Okay, that's nothing more than alcohol, that's 65%. And I don't need much, I just need some in the tip because it's very viscous. And what I'm going to do is, I'm just going to combust it. Okay, so again, what you're doing is, and again, vodka is pretty much pure ethanol, like 80%. And there it is. All you're doing is burning it. And then you're done. And then finally, we have our last reaction. And our last reaction involves, it's probably a reaction that you guys have seen a lot, especially if you have kids. And that reaction is the, it's also called the volcano experiment. What you need to do here is you need to get some baking soda and some vinegar. And what we're going to do is just put some baking soda in a petri dish and then add vinegar to that. And when we do that, we're also going to monitor the temperature. If you have a thermometer, just stick it in there and see what the temperature does when this reaction happens. And here you can see what's going on in terms of the temperature change. And then you can also feel the bottom of that evaporating dish because the temperature change isn't that dramatic. So you can actually feel whether it gets hot or gets cold. And that's that experiment. That's that experiment. You can see that there's a lot of bubbles that form. So let's go ahead and do that. What I'm going to do is not put baking soda in my evaporating dish. I'm going to put some vinegar first in my evaporating dish, and then I'll sprinkle in baking soda. That way I can control things. Here is my, right there. That right there is vinegar. And then I'm just going to take some baking soda and sprinkle in a few. I have a spoon here so that I can control it. Okay, so I have a spoon here, And here is, if you put some food dye in there, it looks really cool. So yeah, food dye. You can have your kids look at this as well. This is what we call the volcano experiment, where it starts to fizz. Okay. The fizzing is a gas that you guys breathe out because it's breaking down baking soda. That is the same gas that is released when you open up a ginger ale carbonated beverage or a Coke or something. But you don't want to drink this one. And that's the reaction right there. Okay, that's the reaction right there. If you have a thermometer or if you want to feel the bottom of this, you can tell whether or not it gets warm or it gets cold. So if you go to the data sheet, and I remind you what you need to complete. Let me show you that real quick. Like the baking soda and vinegar, appearance before. What does the vinegar look like? What does the baking soda look like? Appearance after. What do the two combination look like? What's going on there? Evidence of a reaction. Again, use one of those four that we talked about earlier. Balance the molecular equation. Go to this link right here to see that, yeah, this is a double displacement reaction. And this reaction is very common for baking soda and vinegar. Okay, it's a common reaction that is in the, should be in this particular link. It's a video. The total ionic equation and the net ionic equation. Okay, so you guys had a question like that in your midterm, and we're just getting into doing the experiment now, but remember that we couldn't really do all those experiments before the halfway point, but this should solidify some of those concepts. So make sure you take photos of these things. That's part of your lab, and then answer these pre-lab questions. Explain your own words the difference between a chemical change and a physical change. Okay, in a chemical reaction, what is the solid code that forms when two solutions are mixed? We talked about that. When two solutions are mixed, is a color change always an indicator that a chemical reaction has occurred? Why or why not? What signs of a chemical reaction is not detectable by sight? Okay, you can't see this particular sign that a chemical reaction has occurred. Would you expect a chemical change to always be accompanied by a physical change? Okay, so if there's a chemical reaction occurring, is that always accompanied by a physical change? Or do you think that the physical change will always stay constant? Write the complete ionic equation for this double displacement reaction. So look at how double displacement reaction occurs, and then do this, write the complete reaction. Name and write the formula of the spectator ions in this chemical reaction. And then I think that's about it, okay? Here, check mark all the reaction in this lab which produces a precipitate. Precipitate, again, is when you mix liquids and then you get that brown, that cloudy solution. Okay, you've got to get a cloudy solution and that's a precipitate. If you don't get any clouded solution, or you're not doing any solution, then that's not really a precipitate. Check all reactions in this lab that showed evidence of the reaction that heat is released or absorbed. Okay, do not confuse the release of heat by the fact that you're heating it up with a Bunsen burner or with your alcohol burner. Okay, the reaction itself, once left alone, has got to be able to generate heat. Okay, or it absorbs heat, and when it absorbs heat, it feels colder. Okay, so these are the chemical reactions that you guys did. Some of these will generate heat, some of these absorb heat. Answer all check all the reactions in this lab, which is accompanied by gas evolution. So you got to see like smoke or gas that is produced. Okay. Even when you don't see gas, bubbles indicate that gas is being produced. So that's it. That's your lab. Oh, here are 4. What is the color of the sugar before and after combustion? What is the identity of the gas you observe? Both of these are produced in the reaction between vinegar and baking soda and in the reaction of the combustion of ethanol. Okay, so these are products for these reactions. Write the molecular equation when baking soda and vinegar are combined. So that's basically just this right here. That's this last part right here. Okay, that's the reaction that you guys are, just put that in your post-lab questions. And then don't forget to circle the type of reaction that it falls under. So when you have baking soda and vinegar, that falls under a certain categories of reaction. You need to circle which one. And that's the lab. Okay, that pretty much is the lab. We were able to do this lab in like 30 minutes. You guys are going to do a more thorough job, but I just wanted to demonstrate to you that you guys should have all the materials to do this experiment. You guys have the magnesium ribbon. If you don't have the alcohol, use nail polish remover, or you can use your hand sanitizer. You guys all have sugar in your cupboard. If you've already used the sugar in the last experiment, okay? You guys have salt and water, and hopefully you have a 9-volt battery, okay? And that pretty much is this particular experiment.